The effect of the square root of k over m on the graph of the function. Well, let's see. Square root of k over mt goes through 2 pi radians as t changes by 2 pi divided by the square root of k over m, so that the cycle of the function doesn't last as long. So again, I'm kind of compressing things that should be brought forward from prerequisite courses but aren't always. So here's our function, and now the period of the function becomes 2 pi divided by the square root of k over m. Now there's a symbol we'll use for square root of k over m and so forth, just stressing that the period changes from 2 pi to 2 pi divided by the square root of k over m. And the function goes from y equals negative a, from y equals negative a to y equals positive a. The effect of phi is to change this inner function from the square root of k over mt to square root of k over m times the quantity t plus phi divided by the square root of k over m, which shifts the graph negative phi divided by the square root of k over m in the t direction. So progressively we increase the amplitude of the function by the factor a, we decrease the period by factor square root of k over m, and we shift the graph in the t direction by an amount that's equal to negative phi over the square root of k over m. Now these operations are standard pre-calculus operations, standard graphing techniques, and I'm not going to go into them in a lot of detail. I'm simply going to point out that at this point, if you don't understand how to construct this function, then you probably want to review a little bit of the pre-calculus, and you can let me know. I can give you reference to the places in my Pre-Calculus 2 course where these operations are done.